In this video, I'm going to talk about point-slope form for a form of writing linear equations. I know probably a more popular one is slope-intercept form, y equals mx plus b, but there are times when point-slope form is better than slope-intercept with the y equals mx plus b. Namely, because here's the form of your equation, where m, of course, equals the slope, like it always does. But instead of having to have the y-intercept like you do in mx plus b, you actually just have to have any point you want. So x1 and y1. So for point slope, you need a point and you need the slope. Hey, imagine that. So we can do an example, something like this. Well, if I know my slope is 2/3 and I have a point 6, -3, can I write an equation? Well, sure. Here's my x1, here's my y1, and my slope then is going to be 2/3. So I'm just going to put them straight into this formula. So y minus y1. So y minus my y1 is -3. So always be careful of these signs. Equals, then my slope, 2/3, and then x minus x1, which is 6. So I can clean this up a little bit, and I can say y plus 3 equals 2/3 times the quantity, x minus 6. So there's what my equation will look like in point-slope form. So at this point, you can also go from here fairly simply to slope-intercept form. So all you have to do to change this into y equals mx plus b, right, is to distribute your slope and then put this term on the other side and then combine like terms. So if we did that, y plus 3 equals, let's distribute, so 2/3 times x is 2/3 x. 2/3 times 6, 6 divided by 3 is 2. 2 times 2 is 4, so minus 4. So if we subtract 3 from both sides, we get rid of it there. So y equals 2/3 x minus 7. So if you really like it, here's your y equals mx plus b form, which is slope-intercept. And you can easily find slope-intercept from your point slope simply by distributing and then bringing this term over, and then combining like terms as necessary. In our next example, I want to write the equation of a line that passes through these 2 points, and I want to do so in point-slope form. So what do you need in order to write an equation in point-slope form? Well, you need a point, so we've got 2 of those, and we need a slope. Well, we don't have a slope, but we have 2 points, and we can find it. So the slope is y2 minus y1 over x2 minus x1. So we can say -2 minus a -7 for our y's, and -1 minus 2 for our x's. So -2 plus 7, we go swoosh swoosh, will be 5. -1 minus 2 will be a -3. So our slope then can be -5/3 because we don't want to leave that negative in the bottom. So we have a couple of points to choose from, and we have a slope. Okay, so I'm going to show point-slope form using both of these independently. So I'll use the first point first. So y minus y1 equals x times the, m times the quantity x minus x1. We kind of wrote that backwards there for a second. Okay, so our first point is 2, -7. So -7 is my y, so y minus a -7 equals my slope, -5/3, and then x minus 2. And again, I can kind of fix this up a little bit. So it'll be y plus 7 equals -5/3 quantity x minus 2. So there'll be one of the equations. Well, let's choose the other point now, -1, -2, and we'll get y minus a -2 equals again -5/3 x minus a -1. So when I go through and swoosh swoosh and all these, when you subtract a negative, it's y plus 2 equals -5/3 x plus 1. Okay, so I want to look at these very carefully here. I can't get them both on the screen at the same time. So how in the world can both of these equations be talking about the same line? Well, I think it's a lot better if you put them both in slope-intercept. If we go ahead and drop both of these in y equals mx plus b, I think you'll see they'll end up being the same thing. So let's distribute here. So y plus 7 equals negative 5/3 x plus 10/3. And when I minus 7 from both sides, I'll be minusing 21 over 3. So y equals negative 5/3 x, 10 minus 21 is negative 11 over 3. Okay, so we'll come back to this. Let's go ahead and put this rascal in slope-intercept form. So distribute, distribute. So y plus 2 equals negative 5/3 x minus 5/3. When we subtract 2, it'll be subtracting 6 over 3, which is the minus sign right there. So y equals negative 5/3 x minus 11 over 3. Well, hey, yeah, these were the same things. So even though I was using two different points up here, they were actually serving as the equation to the same line. And I kind of showed that by going ahead and putting them both into slope-intercept form and then seeing that, hey, yeah, they're the exact same equations. So I think point-slope form is a little easier because all you need is a point, which usually are pretty readily available, and then to find the slope. So you don't have to go through the process of finding the y-intercept or some other goofy thing. So all you need is a point and a slope. And there's point-slope form.